Every once in a while, reality itself feels like it's questioning us, like the universe might be just a sophisticated simulation running on some cosmic computer. Imagine waking up one day and realizing that everything you know, from your thoughts to the stars above, could be lines of code in a vast, digital program. The idea that we're living inside a simulation isn't just science fiction anymore. It's a hypothesis that challenges everything about truth, consciousness, and existence. In this video, we'll dive into the fascinating depths of the simulation paradox, exploring whether we're simply algorithms, what that means for free will, and how this could reshape our understanding of the world around us. Stay tuned, because what if reality itself is just a really complex piece of software waiting to be debugged? The genesis of the simulation hypothesis. The idea that reality might be a meticulously crafted simulation has roots that stretch back to philosophical inquiries about the nature of existence and consciousness. It stems from ancient skepticism about the material world, where thinkers pondered whether what we perceive is truly real or just an illusion. In modern times, the hypothesis gained new life with advances in computer science and digital technology. The rapid development of virtual realities, artificial intelligence, and the increasing complexity of algorithms pushed some to reconsider whether our universe could similarly be a highly sophisticated simulation created by an advanced civilization. The conceptual leap was aided by understanding that computer simulations can generate environments indistinguishable from the real world, at least from the perspective of the entities within them. The modern formulation of the simulation hypothesis can be traced to the philosophical musings of thinkers like Nick Bostrom, who proposed a thought experiment that questions the probability of us living in a simulated universe. Bostrom's argument was built upon three key propositions: that technologically advanced civilizations will eventually reach a point where they can run detailed simulations of their ancestors, that such civilizations would be likely to run many of these simulations, and that if this is true, the chances of us being in the original, real universe are slim. This idea challenges traditional notions of a fixed, physical universe and instead suggests that our reality may be akin to what a computer program outputs, an elaborate code running on a vast computational substrate. This line of thinking is reinforced by the exponential growth in computational power and information processing capabilities. As we observe technology barreling forward, self-driving cars, sophisticated neural networks, and even quantum computing, the concept that an ultra-advanced civilization might harness these tools to simulate entire worlds becomes less speculative and more conceivable. Consider the possibility that our universe could be a digital universe, where the laws of physics are simply the rules coded into a cosmic program. Such a view aligns with the idea that what we perceive as physical phenomena are, at their core, data structures and algorithmic processes. The emergence of virtual environments so complex that human cognition cannot distinguish them from genuine reality fuels the plausibility of the hypothesis. In addition, the philosophical implications of simulation theory have prompted debates about the fundamental nature of consciousness. If consciousness can be replicated or instantiated within a simulated environment, then the line between biological and digital life grows blurry. Some argue that consciousness itself might be a pattern of information and that, therefore, a sufficiently advanced computer could generate conscious experience. This opens the door to questions about the origins of our own consciousness, whether it is an emergent property of a biological substrate or the outcome of code written by some higher intelligence. The genesis of the simulation hypothesis is not just rooted in technological speculation, but also in deep metaphysical questioning about what it means to be real, sentient, and self-aware within a potentially programmed cosmos. Assessing the evidence for a digital reality. Leading thinkers in physics and philosophy have pointed out puzzling inconsistencies in the universe that some interpret as signs of a digital framework. Quantum phenomena, such as superposition and entanglement, suggest a level of interconnectedness and discreteness that can be likened to pixel-like units in a simulation. When particles behave differently based on whether they are observed, it hints at a system that responds dynamically, much like rendering engines in computer graphics. This raises the question, could the fabric of reality be encoded, with apparent randomness merely the result of computational processes operating behind the scenes? Advances in high-energy physics have also fueled speculation. Particle accelerators continually push the limits of our understanding of fundamental particles. Some scientists have observed that space-time itself might have a smallest possible unit. Closer inspection reveals something akin to a grid or lattice structure at the Planck scale. Although no conclusive evidence exists yet, such observations have prompted hypotheses that our universe might be a finite simulation, governed by algorithms running on a deeper hardware. These theories gain traction because they could explain why certain phenomena appear digital at their core, such as the quantization of energy levels, which mirrors how digital systems handle information in discrete steps. Moreover, some experimental results appear to hint at the limits of resolution in the universe itself. Physics experiments have detected anomalies that could be interpreted as digital artifacts, patterns that resemble compression or digital noise more than expected continuous signals. If reality were a simulation, these imperfections could be analogous to glitches or pixelation in a virtual environment. Philosophically, this perspective makes sense when considering the simplicity of rules that could produce such complex structures, much like the rules governing cellular automata or fractals, which can generate incredibly intricate patterns from minimal initial programming. However, skepticism remains grounded in the difficulty of tangible proof. The idea that our universe operates on code is elegant, but ultimately untestable with current technology. Detecting an underlying digital substrate would require observations at scales far beyond our reach or insights into the very mechanism that might generate reality. Critics argue that the digital hypothesis, albeit fascinating, risks becoming a philosophical distraction rather than a scientific theory because it hinges on concepts that are inherently unprovable at this stage. Still, as our tools improve and theories evolve, assessing the evidence for a digital universe remains an ongoing endeavor, one that blurs the line between science and speculation. Philosophical implications of living in a simulation. The notion that our reality might be a computer simulation challenges foundational ideas about existence and consciousness. If the universe is, at its core, an elaborate code or a program crafted by an advanced civilization, many questions about autonomy, morality, and purpose take on new dimensions. Philosophically, this perspective blurs the line between what is real and what is artificially constructed, prompting us to reconsider the nature of perception itself. The very fabric of what we perceive as tangible, the laws of physics, the flow of time, even our sense of self, may be mere variables within a vast computational matrix. One of the most profound implications is the concept of determinism versus free will. In a simulated universe, every event and decision could be preordained by underlying code, raising doubts about genuine agency. If our choices are dictated by algorithms and predefined parameters, questions about authenticity and moral responsibility become pressing. On the other hand, some theorists argue that even in a simulation, complexity could give rise to a form of emergent consciousness, preserving a sense of free will. This dialectic deepens when considering whether the simulation's creators have any moral obligation toward their creation, us, or if we are simply part of an experiment with no moral considerations at all. Beyond individual agency, living in a simulation also introduces ethical dilemmas regarding manipulation and control. If we accept that our reality is programmable, then what are the ethical boundaries for those controlling the simulation? It echoes classical philosophical debates about the nature of the good and the limits of power, albeit on a radically different scale. The simulation hypothesis also redefines notions of suffering, joy, and meaning. If they are just coded responses, do they possess intrinsic value, or are they illusions designed to mimic genuine experience? The question extends to whether understanding that we are simulated diminishes the significance of our emotional and moral lives or elevates their importance as reflections of a designed purpose. Lastly, contemplating reality as akin to a computer program impacts fundamental beliefs about the origin and purpose of existence. It prompts inquiries about the intentions of whatever entity or entities crafted the simulation. Are they creating a mirror of their own universe, conducting experiments, or exploring alternate realities for their own curiosity. If our universe is a simulation, it serves as a reminder that our perception of reality might not be fixed but fluid and subject to manipulation by superior intelligence. Such a paradigm shift could profoundly influence our worldview, encouraging a more flexible understanding of truth, existence, and the limits of human knowledge. Challenges and future directions in simulation research. Advances in computational power and algorithmic sophistication have expanded the horizons of simulation research beyond mere philosophical speculation into tangible scientific inquiry. The core challenge lies in deciphering whether our universe is fundamentally a simulation, which pushes researchers to develop increasingly refined tests. These include looking for computational anomalies, such as irregularities or grid-like structures in the fabric of spacetime, that might hint at underlying code. Collider experiments, again, are probing the limits of physics to find signals that could suggest a synthetic structure, yet direct evidence remains elusive. The difficulty isn't just in the technological limitations, it's also about the fundamental nature of the question itself. If we are within a simulation, the simulation might be designed to hide its artifacts perfectly, rendering any attempt to detect it a kind of cat-and-mouse game. Another major issue revolves around the problem of indistinguishability, distinguishing between a universe that is really physical and one that simply appears physical because it is coded that way. Researchers debate whether future experiments could ever definitively prove a simulated reality or simply push the boundaries of what we can observe and measure. If the simulation hypothesis is true, it would imply a layer of reality beyond our reach, possibly inaccessible by any conceivable experiment. Efforts to identify glitches or disparities often run into the problem of false positives. Natural phenomena can mimic anomalies, making the validation process complex. These challenges highlight the need for creative, interdisciplinary approaches. Insights from computer science, quantum physics, and even philosophy must converge to deepen our understanding. The future of simulation research might involve exploring the nature of consciousness itself. If our minds are emergent properties of neuron networks, could they also be simulated or encoded in a digital framework? This leads into questions of free will, subjective experience, and the very fabric of reality. Developments in neural interface technology and quantum computing give hints that we are approaching a point where consciousness and its potential simulation could be experimentally interrogated. Additionally, ethical considerations may become central. If we can simulate conscious beings, do we have moral obligations? Should we consider the possibility of creating increasingly complex virtual worlds that might host sentient beings? As technology marches forward, the line between simulation and reality may become more blurred, prompting profound shifts in both scientific and philosophical perspectives. Ultimately, progress hinges on an openness to multiple theoretical frameworks. Whether the universe is a vast simulation or a fundamentally indeterminate quantum field, future research needs to rigorously explore both sides of the debate. As computational models grow more sophisticated, scientists have the opportunity and the challenge to replicate aspects of physical laws within virtual environments to see if emergent phenomena resemble our universe. These experiments could serve as thought laboratories, providing clues about the nature of reality and whether it may be simulated at a fundamental level. The ongoing quest involves balancing skepticism with curiosity, recognizing that each new insight could radically alter our understanding of existence itself. The core idea of the simulation hypothesis hinges on the possibility that our entire universe might be a sophisticated computational construct, crafted by an advanced civilization or entity that surpasses our current understanding of technology. This concept raises intriguing questions about the nature of reality itself, suggesting that what we perceive as physical laws could simply be code embedded within a vast digital system. If true, our memories, thoughts, and physical interactions would be nothing more than data points processed by this giant simulation. Modern advancements in quantum computing and artificial intelligence, even at their nascent stages, support the plausibility that such hyper-advanced simulations are conceivable, raising the question, if it's possible, are we already inside one? One compelling aspect of the simulation hypothesis relates to the nature of consciousness and perception. Some theorists argue that consciousness might be a computational phenomenon, emergent from the complex interactions of simulated neural networks. Experiments with neural correlates of consciousness and the realization that consciousness could be simulated or replicated in computer systems lend weight to this idea. If consciousness can be instantiated within digital environments, then it's conceivable that our own sense of self and subjective experience are just complex algorithms running inside a program. This perspective aligns with digital physics, which interprets the universe as information processing, blurring the lines between physical reality and software. This line of thought also pushes questions about the flexibility of our universe's rules. In a digital realm, limitations, such as the speed of light or the quantization of energy, might be artifacts of rendering constraints or optimization techniques used by the creators. For instance, phenomena like teleportation, quantum entanglement, or the holographic principle could be interpreted as glitches or shortcuts within the code. If we accept that the universe has a base code, then anomalies or inconsistencies long observed in physics could be signs of the underlying programming rather than genuine physical mysteries. It becomes a kind of cosmic debugging. What we perceive as mysteries are just facets of the simulation's architecture. Finally, this raises profound philosophical questions about authenticity and free will. If everything is code, is agency an illusion? Are our choices determined by preset algorithms encoded in the universe's fabric? Some argue that even within a simulated reality, complex decision-making and emergent behaviors might appear genuinely autonomous, fostering a sense of free will. Others see it as a deterministic experience akin to a closed systems game, where the illusion of choice is built into the simulation parameters. Deciphering whether we are truly free or simply following lines of code could reshape the way we understand morality, purpose, and the nature of existence itself, blurring the boundary between reality and virtuality so completely that one might never confidently distinguish the two. So, as we wrap up this journey through the simulation paradox, it's clear that the idea of our reality being a vast, intricate program raises profound questions about existence, consciousness, and the universe itself. We've explored how the hypothesis challenges our perception of what's real, probing whether our universe operates like a code running within a higher dimensional system. It's a mind-bending concept that invites us to reconsider everything we thought we knew about reality's nature. Are we merely characters in someone else's algorithm? Or is there something more fundamentally genuine about our experience? If this spark of curiosity resonates with you, first invite you to stay tuned for upcoming videos where we'll dive even deeper into these questions, exploring the scientific theories, philosophical debates, and technological implications behind the simulation hypothesis. Your thoughts and perspectives are what make this exploration worthwhile, so don't hesitate to share your insights or questions in the comments. Together, we'll keep unraveling the mysteries of existence and maybe, just maybe, get a little closer to understanding what it means to truly be alive in this extraordinary universe. Thanks for watching, and first look forward to exploring the possibilities with you in our next adventure.